Hi everyone, a very good evening to all. Today we are going to study about kinetic theory of gases. So here on what basis questions will come that we have to understand. Like here, very first thing when you consider what are the assumptions of kinetic theory of gases. So kinetic theory of gases says all the gas molecules are tiny spherical elastic bodies, elastic particles. And pressure due to an ideal gas is due to collision of gas molecules with walls of container, and all the gas molecules move randomly with random velocities. So this is what kinetic theory of gases, main important points. Now based on this, we get the equation like what is the pressure of an ideal gas. So pressure of an ideal gas is given by P equal to 1 by 3 Nm V square bar. Nm by V, or else P equal to 1 by 3 rho V square bar, where density equal to mass by volume, where M is mass of each molecule. Capital N is total number of molecules. So total mass will become N into M. Total mass by total volume will become density. So here, if you multiply this equation with 2 and divide with 2 equation, 2 by 3 into 1 by 2 Nm V square bar, this is nothing but kinetic energy. So that kinetic energy will become, sorry, here V is also there, V you bring this side. So that 3 by 2 PV or 3 by 2 nRT. This is for n moles. Now for 1 mole, when you consider, the kinetic energy will become 3 by 2 RT. Now this is called like kinetic interpretation of temperature. So kinetic energy in terms of temperature. So now when you consider like consider a gas having n number of molecules with speed V1, V2, V3, so on, Vn. Then average speed equal to V1 plus V2 plus so on, Vn by n equal to under root 8 RT by average speed will become 8 RT by pi m. And another one is RMS speed. RMS speed means under root, see, root of mean of square of the speeds. See, let's like what are all the speeds and energy of a gas molecule means. One is average speed, that is under root 8 RT by pi m. And another one is, so root means square velocity, that is root mean square means under root V1 square plus V2 square plus so on Vn square by n. Mean of square of the speeds under root. That only will become under root 3 RT by m. And Vp, most probable speed is 2 RT by m. These are the different speeds a gas molecule can have. And what is this most probable speed is? Most probable speed means most number of particles will acquire one common velocity. That common velocity is called most probable velocity. And when you consider energy, we have taken like 3 by 2 RT. And that we will divide like 1 by 2 RT, 1 by 2 RT, 1 by 2 RT. Now, where 1 by 2 RT is energy, kinetic energy per molecule, per mole per degree of freedom. Means this is called law of equipartition of energy. When you consider monoatomic gas, the number of degrees of freedom 3. When you consider diatomic, number of degrees of freedom 5. When you consider triatomic, number of degrees of freedom 6. So what is number of degrees of freedom is number of independent motions. And law of equipartition energy says each one particular degree of freedom, each particular independent of motion is associated with certain amount of energy, that is 1 by 2 RT. Suppose if they ask per molecule, this is for 1 mole. Per molecule means, see, per molecule when they ask the energy, then 1 by 2 RT by any Avogadro number, then that will become 1 by 2 kT, where K is Boltzmann constant. So they can ask per molecule, they can ask per mole per degree of freedom, or they can ask total. But when they ask suppose diatomic gas, out of 5, 3 are translational motion, 2 are rotational motion. Triatomic means F equal to 6, 3 are rotational, 3 are translational. So when they ask kinetic energy of a gas, you must understand whether they are asking per molecule or per mole per degree of freedom, or only translational kinetic energy they are asking, or only rotational kinetic energy they are asking, or total energy they are asking. You must know the clarity, then only you can solve it. Now, based on this, let's see a few questions. Two gases A and B at STP occupy a volume 2 liter each. If the two gases are mixed in a vessel of capacity 2 liter at the same temperature, the pressure of the mixture is, see, one is one vessel, this is V1 is 2 liter and V2 is also 2 liter. Now at STP, standard pressure like 1 atmosphere, temperature 27 degrees Celsius. Now they mixed into one final volume of again 2 liter. The pressure of the mixture. Now number of moles remains same. And according to ideal gas, P1 V1 by T1 plus P2 V2 by T2 equal to P into V by T. So now they are telling that they are at same temperature. So T equal to T1 equal to T2. Initially they are at STP, finally also at, standard temperature only. So that get cancelled. Then V1, V2 each is 2 liter. V is also 2 liter. Then V1, V2, V also get cancelled. Then finally if you get the equation P equal to P1 plus P2. Standard temperature means 1 atmosphere. 1 plus 1, 2 atmosphere. So like that you need to understand. 1 mole of an monoatomic gas is mixed with 1 mole of diatomic gas. What is the molar specific heat of mixture at constant volume? See here, for a mixture, CV mixture equal to N1 CV1 plus N2 CV2 by N1 plus N2. Now CV equal to FR by 2. Now here CV1 for monoatomic gas F is 3R by 2, and CV2 mixed with diatomic gas, so 5R by 2. Now C1 V1 CV1 CV2 we got it. Now N1 is 1 mole, N2 is also 1 mole. Now you can get CV mixture. Then you have to find CP mixture, that is CV mixture plus R. Then what is the molar specific heat of the mixture at constant? Only CV mixture they are asking. So if they ask CP mixture, you can find this. Or sometimes they can also ask gamma mixture, where it will become CP mixture by CV mixture. So this kind of question they can ask based on the mixing of gases. Now find the average speed of nitrogen molecules at 27 degrees Celsius. So V average means under root 8 RT by pi m, where m is molecular mass. Nitrogen means 7. 7 means 14. 14 to the 28 into 10 power minus 3. This is molecular mass of N2. Now capital R is 8.314 and temperature is 27 degrees Celsius means 27 plus 273 300 Kelvin. Now just substitute all the values, then you can calculate. But while taking the calculation, I used to say take the approximation, then only you can do the calculation easily. Next, in a container, two gases, neon and argon are filled. Find the ratio of root mean square speed of the molecules of the two gases. See, root mean square speed means under root 3 RT by M. The temperature of the system. So temperature is same, R is constant. So now the relation you can take is Vrms is directly proportional to 1 by root M. Now V for neon by V for argon equal to under root M for argon by M for neon equal to under root M for argon is 39.9 by neon 20.2. So it is approximately like 2 will come or less than 2 will come actually 1.9 something. Now at what temperature the kinetic energy of a gas molecule is half of the value at 27. Kinetic energy of a gas molecule. One molecule means 1 by 2 kT. So the kinetic energy is proportional to temperature. Now E2 by E1 equal to T2 by T1. So the kinetic energy of the gas molecule should become half. That means E2 should become half of that one, E1 by 2. Now if you substitute E1 by 2 by E1 equal to T2 by T1 is 27 plus 273. So E1 get cancelled. 1 by 2 equal to T2 by 300. So T2 will become how much? 150 Kelvin. Or they can ask in degrees Celsius also. Subtract 273. So this is the way simple questions they can ask based on mixing of gases, law of equipartition of energy and speeds of different gases, different speeds of a gas molecule like average speed, RMS speed and most probable speed. So similar questions I have given as an assignment. So just try to understand and try to solve. Then you will get the idea how to solve the questions. So thank you all. We'll continue in the coming session with the next question.